Okay, everybody. So, section 5.3, we're doing radical equations. By the way, you'll need this stuff for sure if you're taking calculus next year, so make sure you know how to solve these equations. Okay, also if you're doing math 12, you'll see this stuff again, so make sure you pay attention here. Okay, now I gave you some hints above, right? I said if you want to figure out these radical equations, the idea is to isolate the radical. So can you tell me what my first step should be if I want to isolate the radical on the left side? Yeah, let's get rid of this positive 3. We'll subtract 3 on both sides, so we get the square root of x minus 1 equals x minus 3. That's a good first step. Okay. What's next? Square it. Once you isolate the square root, square both sides. So you square the square root, which means you're just left with the radicand, the stuff underneath. Be careful when you square the other side. Don't say it's x squared minus 9. Remember, it's x minus 3 times x minus 3, so that's a perfect square. How about x squared minus 6x plus 9? Okay. Now, this is good because, look, your square roots are now disappeared. You can just move all the terms to one side and solve. So x squared, I'll move the negative x, or sorry, I'll move the positive x to the other side. That becomes negative x. So minus 7x. And then I think I'll add 1 to both sides. So how about plus 10? This equals to 0, and this is why we did chapter 4 first. You should be able to solve this now. Factor, can someone help me factor this, please? 5 and negative 2, thank you. So x equals to 5, x equals to 2. Okay. Now, ladies and gentlemen, with these square root functions, can you please plug it back into check? Because some of these actually don't work. Even though the algebra makes sense, you have to plug it back into check. So let me check x equals to 5. And of course, when I plug it back into the original. 3 plus, now 5 minus 1. What's 5 minus 1? 4, square root of 4 is 2, 3 plus 2 is 5. That equals to x. That works. Okay. But if I try x equals to 2, 3 plus, and this is 2 minus 1, does that equal to 2? In this case, I believe no. So therefore, your x equal 2 answer is what we call extraneous. Okay. And therefore, x equals to 5 is the only solution. Okay? The only solution. So that's the general characteristics of how you solve A. Okay. B is very similar, except now you have 2 square roots, and when you have 2, don't worry, the steps are the same. But my suggestion to you is always isolate the more complicated square root first. So isolate more complicated square root first. So let me ask you, which one should I leave on the left side then? The root x or the root x minus 3? I will leave the root x minus 3, yes, which means I need to take that root x and move it to the right side. Okay. Yes, Steve. Yes, Shane. Yes? Ah, oops. Thank you, dear friends. I forgot about something for A. Yeah, we call them restrictions here. So remember, the restrictions is that the stuff underneath the square root, which in this case is x minus 1, has to be non-negative or bigger or equal to 0. So therefore, in this case, the restriction here is x actually is greater or equal to 1. Okay? Now, you might be thinking, Mr. Lee, your restriction is x is greater than or equal to 1, but look, your answers here were 5 and 2, but 2 didn't work in the end, so what's up with that? Okay, now this is where it gets complicated if you really want to talk about restrictions. Okay? So once again, if you check both answers, you're guaranteed to not make mistakes. But if you're looking at the restrictions here, x is greater or equal to 1, yes, it's true. It's a restriction on the square root part, but is that the real true restriction on x? Let's think about this. Can we look at the left side here? 3 plus root x minus 1. What's the smallest this root x minus 1 can be? The smallest it can be. I heard it. 0, right? The square root of a number, the smallest it can be is 0. So this is 0. 3 plus 0 gives us 3. So therefore, really, if I were to look at this part and say, what's the restriction on x, since x is on the right-hand side, I'm saying that the left side here has to be bigger or equal to 3. Can you see that? And that's the reason why 2 doesn't work. Because really, it's implied here that x actually is greater than or equal to 3. You can. So, ladies and gentlemen, when you do these square root functions, that's why it's a little bit confusing when we talk about restrictions. Okay? Yes, there's a restriction on the root part itself. But in this particular case, because the whole left side is equal to x, there's an additional restriction that, hey, that left side has to be bigger or equal to 3. And so therefore, your true restriction, I'll say for this one, your true restriction is really for this one, x is greater or equal to 3. Okay, star that. And that's the reason why this x does not equal to 2, or x can't be equal to 2. Once again, if you don't want to be complicating yourself with this restriction stuff, you can just solve as is, but double check your two answers by subbing it back in. It's your choice. Okay? Thanks, Shane. That's a good question. Johnson. On the test, I won't ask you to write a restriction. I'll ask you to solve. Yes. Okay? But then up to you. You either check or you do that. Yes. Okay? Okay, sorry about that. Yes, Hisham. Okay, ladies and gentlemen, good question here. Could there be a possibility that both answers are extraneous? You bet. Okay, so that would be then no solution in the end. Am I that kind of tricky person? No. Okay, part B, please. So once again, we isolate it. And by the way, for those of you who want to look at restrictions right now for part B, the restriction here is x must be greater or equal to 0. And the restriction here must be x is greater or equal to 3. So overall, what do you think your total restriction should be? Yeah, your restriction really should be just greater than or equal to 3. The overall restriction. Okay? So if you like doing restrictions, that's what you say. Those of you who don't like doing restrictions, that's fine. Let's continue to try to solve. I've separated the two square roots, one on the left, one on the right. What should I do next? How about square both sides? So go ahead and square both sides, please. What's x minus 3 all squared? That's x minus 3. What's 5 minus root x all squared? Well, once again, be careful when you expand this out. This is 25. I think minus 10 root x plus, and root x all squared is just x. Yes. Okay. So once again, if you're not too sure what I did here with the square, remember it's 5 minus root x times 5 minus root x. Go ahead and distribute. Distribute. Okay. Once you're at this step, collect like terms, and let's see if you can isolate the root x again. So I think I'll move this over. So this is negative 28 equals to negative 10 root x. Where did I get the negative 28 from? I took this 25 from the right-hand side, moved it to the left-hand side. Okay. Now, once you're at this step, you have choice. Some of you might think, I'll square both sides like this. That's perfectly fine. Just make sure you also square the negative 10 to become 100. So you get, what's 28 squared? 784, I think. Okay. And when you solve, you get x equals to 7.84. Okay. Now, some of you might be thinking, Mr. Lee, I don't like those big numbers. Okay. So if you don't like big numbers, someone else might have said this. Mr. Lee, I thought you said we should isolate the square root. You didn't isolate the square root. There's this negative 10 here. Okay, I'll isolate the square root now. If I wanted to do that, I would take negative 28, divide that by negative 10, and that means now I've isolated the square root. Well, what's 28 divided by 10? That's 2.8. Okay, so now if you left it like this, yes, you can square both sides. But if you square both sides, you get the same answer. X is still 7.84. Okay, same. It's up to you which method you like. It doesn't matter to me. Okay? Now, because I have looked at the overall restriction, I can say that, is this answer bigger than or equal to 3? Yes. So I know this works. If you didn't do the overall restriction and you wanted to check, you could do that as well. Type in 7.84 the square root, take 7.84 minus 3, take the square root of that, and see if it equals to 5. Okay, I'll say, because I want to save some time, it's yes. Okay? Okay, ladies and gentlemen, can I ask you now to try example 3 on your own right now? Okay, so see if you can do this. It's very similar to number 2b, so I'm going to give you a few seconds to try this before I move on to next stuff. Okay? All right, so I've already squared both sides once, and I've simplified. Now what should I do? Now, ladies and gentlemen, a lot of the times I prefer to try to isolate the root, but because if I divide by 6, I'm going to get fractions, I'm afraid of fractions. So because I'm afraid of fractions, what will I do now? I will actually square both sides again at this step, okay? Be careful how you square the right side though, okay? So the left side, 4x minus 6 all squared, 4x all squared is 16x squared. 4 times 6 is 24 times 2 I think is 48, so 48x plus 36. Is that correct? Yes. Okay. Now, here's the tricky part for the next side. Listen up. That square needs to be distributed to both things. So the 6 gets squared, which is 36. And then the root x plus 3 gets squared, which becomes? And please do not forget to put a bracket around it. Okay? Because that 36 applies to both of those terms. So now we get 36x plus 108, and the left side stays the same. I think this is where you're trying now to simplify. So I will simplify. I get, I think, 16x squared. What's 48 and 36 together? 84 minus 84x. 36 minus 108 is 72, is it? Minus 72? Good. Okay. Now, shh, quiet please. Once you get to this stage, your numbers are still big. You might want to factor. Can someone tell me what number divides evenly to all these? 4. Oh, okay. Shh. I heard some terms. Someone whispered to me, quadratic, quadratic. Okay, so once again, if you don't want to factor, go ahead and use the quadratic formula. Yes. Okay, so go ahead, try it. Negative b plus or minus square root of b squared, so that's negative 84 all squared, minus 4ac all over, right, so that's 32. Okay, the numbers look bad. Yes, but then remember it's negative b, right? So negative of negative 84 is positive 84. Yep. Can someone help me out? What's the stuff inside this square root here equal to? I don't want the answer, I want that part. 729? Really? Oh, okay. What's the square root of 729? That's a nice number, isn't it? What is it? Oh, 20 what? 27? So I'm just trying to show all the work here. 84 plus or minus 27 over 32. No, that's not right. Do I have to do it myself? Okay. Thank you. Okay. So once you get to this step, you can find your two answers. So 84 plus 108 divided by 32, and I believe that answer is what? That's 192 over 32. I think that's 6. Okay? Or what else? Yeah, negative, and I think that becomes what? How much? Okay, negative 3 over 4. I think I get negative 3 over 4. Okay. Now, ladies and gentlemen, quiet down, please. Okay. So here are my two answers, and because you did not look at the restrictions, I'm going to ask you to now check both those solutions. Okay. Now, if you don't want to, then I would strongly suggest you think about the restrictions. So let me go back up to the top and let's talk about the restrictions. What's the restriction on this x plus 3 over here? X has to be greater or equal to negative 3. How about this one over here, the 5x plus 6? What's the restriction on that one? Negative 6 over 5. So you're thinking, well, let me take the bigger of the two. So the overall should be x is greater than negative 6 over 5. Wait a minute, both these answers over here of 6 and negative 3/4 are also bigger than 6 over 5, so we're okay. Once again, not exactly. Why? Let's take a look. Okay. You see how there's a left side and you see how there's a right side? Listen up, please. Okay, listen up. Once again, listen up first. You see how we have a restriction on the right-hand side here? The stuff with the square root means that, hey, this whole value, okay, the whole square root value here, what's the smallest it can be? 0, right? The square root of any number, the smallest number is 0. So the square root of 0 is 0. 3 plus 0 means that it's equal to 3. So that means that, hey, this stuff on the other side has to be at least the number 3. Okay, so once again, the right side here, the smallest it can be is 3. Because this is an equality, therefore the left side here, this must also be equal to 3. So therefore, the overall restriction, okay, overall restriction here is that x must be bigger or equal to 3. And because that's the case, look, your solution over here, the only one that works is 4. This one's extraneous. Okay? Let me just pick up the phone first, and then I'll answer your question. Okay, so my overall restriction actually is not x is greater or equal to 3. Okay? I stand corrected. Now, listen up, okay? What I did tell you, Johnson, please, okay? What I did tell you about the right-hand side here is correct. So, this is the smallest it can be is 0. Agreed? 3 plus 0, of course, is 3. So the minimum, the smallest this side could be is 3, which means that the smallest the left side could be, okay, is that the whole left side must be bigger or equal to 3. Okay? Now, what does this mean? Well, if I were now to square both sides, I have 5x plus 6 is greater or equal to 9. Which means if I continue to do algebra, 5x is greater or equal to 3, right? 9 minus 6 is 3, right? And then, if I want to solve for x, that technically means x must be greater or equal to 3 over 5. So this is your actual overall restriction. My fault. Okay? Now, like what your student said, wow, this overall restriction stuff is so nasty, just go back and plug it in and check. That's fine if you want to do that. Perfectly fine. Yeah. Okay? So, if you think it's easier to plug it in and check, just plug it in and check. All right. Some honor stuff now, just for you. Okay, 4A and B. B is fun, by the way. Okay? All right. I've shown you how to do square roots. What about cube roots? Now, first of all, are there any restrictions for cube roots? No, because it can be positive, it can be negative. I can take the cube root of negative. So because this is a cube root, I'll say no restrictions for the cube root function. Okay, so we're good. Now, how did I get rid of the square root again? I squared both sides. So how do you think I should get rid of a cube root like this? Just cube both sides. That's right. Cube both sides. So if I were to cube this and cube that, well, I just get x squared minus 1 on the left. 2 cubed is just 8. So what happens here? X squared equals to 9. X equals to plus or minus 3.
These are too easy.
Now, once again, you should check.
That's it?
Okay? Yeah, that's it.
Oh.
Okay, but I'll say both of them work because they work. Okay? So, don't freak out if I give you a cubed. The idea is very much the same. All right, part B. Okay, this one is really nasty.
That's why you've been trying to like make rooms.
Make room, yes, make lots of room. Only for you guys, since you're in my honors class.
Is this on my test?
Will this be on the test?
You know.
I don't know. I haven't made up the test yet. We'll figure it out. Okay. Shh. By the way, did you make these changes? This should be a 1 here, and this should be a 0, right? I know you still don't get it, but those are the changes. Make those changes. Okay. Here's a little trick for this one. That stuff underneath the square root looks really ugly, right? So I'm going to say to you, when something is really ugly, in the past, when we did this with chapter 4, I said let it equal to some other letter as a substitution. Okay, perhaps it equals to A or B or whatever I used. But if I were to make this equal to A, you're still thinking, well, what else is equal to A or A squared or something else? And you may not be able to see it. So there's a trick for this one, okay? Just watch me for a sec. Don't write this down. Can you see how the x squared and minus 3x sort of appear here? What would I have to do to make it appear there? Factor out of 2. Good. But notice it's only x squared minus 3x. I have a 1. There's no constant next to these two terms in front. So here's what I'd like you to do. I want you to take this number, -5, and I want you to break it up. Okay? Break it up so you can actually have a constant next to the 2x squared minus 6x. Now, which constant do you think I want next to this? Once again, you see how this is x squared minus 3x minus 1? This is 2x squared minus 6x, and what should I have here to kind of make it? So ladies and gentlemen, watch me first, and I'll let you write this down. You'll have 2x squared minus 6x, and this is the idea. I want you to break up the -5 into a -2, and then what's left over? Probably a -3. Okay? So watch me, please, as I do this first, and I'll give you time to write this down. So notice what I did. I took the -5. I had to break it up into parts, kind of like we did with completing the square. And then I put a -2 with the first two terms because now, if I were to factor out the 2, you get x squared minus 3x minus 1. Well, look at that. That looks like exactly the same thing underneath my square root. And therefore, what I'm going to ask you to do is let us use a substitution. Let A be equal to the square root of x squared minus 3x minus 1. And I'll give you time to write this down, don't worry. So therefore, what does this simplify to? We have a 2, and this would become a what? A squared minus 5a minus 3. Look at that. It's time to factor. So I'll give you a chance now to write this down, and I'll give you a chance to factor, and let's see if you can do that, and we'll continue. Did you factor this for me? A minus 3. 2a plus. Good. Okay. Now, ladies and gentlemen, let's stop talking, please, so we can get this done. Now, not done yet because you need to solve for, I guess, a. I guess in this case, a equals to 3. Over here, a equals to negative 1/2. Now, that's a, but what did I ask you to solve for? X. So go ahead and resubstitute now. And I'll say the square root of x squared minus 3x plus 1 equals to 3. And over here, I'll say the square root of x squared minus 3x plus 1 equals to negative 1/2. Good. I hope you see something, dear friends. The one on the right-hand side here. Can the square root of whatever ever equal a negative number? So guess what? No answers from this part. Okay? Just a no answers. Okay, no answers because I'll say the reason is because the square root can't be equal to negative 1/2. Okay? So you're actually saved. You only need to solve one more part, which is the one on the left side. How will I solve for x in this case? Once again, square both sides. So x squared minus 3x plus 1 equals to 9. And then what? Move to one side. X squared minus 3x. What is this? Minus 8. Ew. Does that even work? Yes. Where's the confusion?
A minus 3. So it should just be x squared minus 3x. No, it wasn't plus 1. It's minus 1. If you look at the top.
Oh, it's minus 1. Oh, I see. I see. My fault here. Okay. Yes. Yes. Thank you. Thank you. Thank you. Thank you. So minus, minus, minus. Sorry. Well, you know what? What happens when you get too excited? You make stupid mistakes like this. So that's why you have to be calm, cool, and collected when you do the math. Yeah, you guys get too excited during tests. That's why I stopped giving you candy. That too. Okay, so factor this. What do we have? Take away 5. How about add 2? So here we go. X equals to 5. And x equals to negative 2. And I guess you should go back and try to check. I'll let you try this at home. Check. But I think they're okay. Alright? Take your chances. Okay. This could be a bonus question and test. I don't know if it'll be an actual real question and test. We'll find out. Okay. One question test, right? You asked for it. Alright. So here we go. We have this question where it says point P lies on the y-axis. So if I were to draw my axes, okay, x and y, you've got this point P, which is anywhere along the y-axis. I'm just going to put it up here for now. But it could be anywhere. It could be positive. It could be negative. I don't know. So let's call this point P. By the way, what's the coordinate of point P? 0 for x. And we don't know what y is, so let me just call it y. Okay? Now, it also says the coordinates of r and s are negative 21, 0. So here's r, negative 21, 0. And s, which is over here, positive 15, 0. And the question here says the sum of the distances of PR, so I guess that's this part here, PR plus PS, which is this part, is equal to 54. So the whole distance. So the distance of PR plus the distance of PS equals to 54. So I guess what you need to do here is you need to find an expression to calculate the distance PR and also PS. Okay. Now, I didn't actually show you something called the distance formula. There is a formula that you can use to calculate the distance between 2 points. but I'm not going to show you that. You might have done that last year. You can use that if you want, but if you forgot, okay, what I'm going to say to you is this. Look at the triangles, okay? Triangle, triangle, triangle. See a triangle? What type of triangle? I heard it. So what do we use when we use right triangle triangles? Pythagoras. What is the actual distance from there to there? 21. What's the distance from the origin to that point y? We call it y. So therefore, PR would be a squared, 21 squared, plus b squared, y squared, and then don't forget to square root it. Okay, so there's your expression for PR. It's just the square root of, and I'll do 21 squared, that's 441. Maybe I should color code this. I'll color code this. Root 441 plus y squared. Okay? Now you take the next 15 seconds on your own to try to come up with the formula for PS, please. Okay, it's very similar. Okay, try PS on your own. So once again, using Pythagoras, can someone help me out with that PS now? Okay, what would PS be equal to? 15, I heard? Okay. 15 what? Squared plus y squared, square root. Good. And 15 squared is 225. Okay. So ladies and gentlemen, here is your equation that describes this scenario. The length of PR, which is the square root of 441 plus y squared, plus the length of PS, which is the square root of 225 plus y squared, and this whole thing equals to 54. Okay? Now, the rest of it is up to you. Okay? So square both sides, all that kind of stuff. You do this at home. Okay? And I'll tell you the solution here as well, but I want you to try to find it. Okay? Y equals to, I think it's plus or minus 20. So the coordinates of P, so I'll say therefore the coordinate of P, okay, you have two possibilities. It can be above the x-axis, so that's 0, 20, or also below the x-axis, 0, -20. Okay? Right? This point P could be up top. I can move it down. It could be below as well. Okay? This one also has what we call a finite sum. Okay? So this thing goes on forever and ever. Root 2 plus root 2 plus root 2 forever and ever. But I think there's actually a number that this attaches to. So why don't you bring your calculators right now, and I'm going to ask you to actually punch this into your calculator and see what decimal approximation you get. Okay? So take out your calculators, please. I'll take out mine. You take out yours. Okay, and I want you actually to type this into your calculator and see what actual decimal you actually get. So I'll do the first one with you. Root 2 plus root 2. And then don't forget to close your brackets. And I got about 1.84. So I'll write this down. I'll say this is 1.84775 9065. Okay? Now, dear friends, I want you to try the rest of them right now on your own. Okay? And let's see if you can get decimal approximations and write them down. Okay, and if you want to look at how you can type this in, I'll do one more with you. It's the square root of 2 plus the square root of 2 plus the square root of 2. Now start closing the brackets. Close the first one, close the second one, close the third one. Did you get 1.96? Okay, good. How about the rest of them? 1.96, blah, 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 blah. Does someone have the answer for the next one yet? 1.99, okay. And then what's the next one after that? Well, it's not 2 yet, right? 1.99759. Okay. Now, I'm asking you to use your super investigative skills to predict what you think this whole thing is actually equal to if I went forever and ever and ever. So if I were to do more and more and more and more and more, okay, 1.999, which equals to, that's right. So this thing equals to 2. Now, prove it to me.
Well, because you get 2 plus 2, square root of 2 plus 2.
That's not good enough proof. Because that actually equals 1.9999. Because you said so. Even worse proof.
No, but like...
It's the worst proof.
No, that's what I'm asking. Isn't it like square root of 2 plus square root of 2? That's the same thing as writing like square root 2 plus 2.
Let's take a look.
That's what I'm
Okay.
saying. Then like, so at the end of the day, what you do have like, just at the end of the day, you have like square root of 2 plus 2.
Well, let's take a look, Gavrilo. I think Gavrilo's on a good step here, okay? Now, we're trying to solve this thing, right? So let me call this whole thing x, okay? So just write this out with me. Humor me, please. Okay? Shh.
You're making fun of my English.
All right. Let's take a look together, okay? I only got about 5 minutes left. Now, can someone tell me if this whole thing goes on forever and ever and ever, and this equals to x, can you also see the value of x somewhere in here?
Yeah.
Where?
Where that 2
Where this starts?
Yeah.
Okay. Hisham says, yeah, Mr. Lee, this stuff here is the same as what you just wrote down up here, because this goes on infinitely forever and ever and ever. You're right. What did I just call that? I called that x. So this whole thing here is also equal to x. So therefore, x equals to root of 2 plus x. Think about that. Okay. You can start from anywhere, you're right, but then I'm going to start here so that it makes it a little bit easier for me. I don't have to square so many times. That's what I said, x equal to. All right, let's go ahead and solve now. Square both sides, dear friends. So x squared equals to 2 plus x. What do we do next now to try to solve? Don't square root now. If you square, we get back the same thing. Move everything to one side first. And then you should be seeing this and thinking, oh, factor. Help me out, somebody. What are my 2 numbers that I use to factor here? Right. So therefore, x equals to 2 or -1. Of course, this can equal 2. Thank you, Hisham, because it's an extraneous root. So there you go. Here is your proof, not because I just said so. Here it is. X must equal to 2.